What if I told you that the invention of the shipping container did, well, absolutely nothing to cause modern globalization?
Yeah, that is a tough sell.
Right. Or that laying thousands of miles of fiber optic cable across the ocean floor wasn't the catalyst that suddenly connected the world economy.
Which goes against basically everything we are taught.
Exactly. Because if you are like most people, that probably sounds completely backward. We all share this very intuitive assumption that massive technological breakthroughs are the undisputed engines of global integration.
I mean, the narrative is incredibly comforting.
It really is. Human ingenuity invents a faster machine,
Right.
and that machine destroys the barriers of physical distance, and then human behavior simply follows the newly paved road.
It is a clean, appealing storyline
Hmm.
because it places the physical invention right at the center of the universe.
Yeah.
It treats technological progress as, like, an independent force of nature that descends upon society and reshapes our habits. You see a faster mode of transit, you observe the world getting smaller, and you just naturally assume the former caused the latter.
Okay, let's unpack this. For today's deep dive into the source material, we are totally dismantling that clean storyline.
We really are.
We are pulling from a deeply researched National Bureau of Economic Research working paper by economists David S. Jacks and Krishna Pendakar.
It is a brilliant paper.
It is. And to understand the modern world and perhaps reevaluate how you view today's tech booms, we are traveling back to the late 19th century to investigate an earlier death of distance.
Specifically, the steamship revolution.
Right. The mission here is to answer a surprisingly elusive question. We always assume faster technology automatically equals a smaller, more connected world, but is it really that simple? Do transport improvements actually cause globalization, or is it possible we have the cause and effect completely flipped?
And, to even begin approaching that question, you have to grasp the sheer, unprecedented scale of the economic boon these researchers are trying to decode.
Oh, the numbers are wild.
They really are. We are focusing on a very specific transformative window of history, the period from 1870 to 1913.
Right.
This era is often regarded as the golden age of the first great wave of global economic integration.
And looking at the raw historical numbers from that 43-year stretch, the correlation seems undeniable.
Oh, absolutely.
I mean, average maritime freight rates, the cost of shipping goods across the ocean fell by an average of 50%,
A massive drop.
while global trade volume exploded by an astonishing 400%.
Yeah.
Now, to ground this analysis, the authors used the United Kingdom as their primary lens. The UK was the dominant economic hegemon of the era, but fundamentally, it was an island.
And that geographical isolation is crucial.
Right.
Because the UK was entirely separated from its trading partners by water, every single piece of international commerce involved putting cargo on a ship.
Yeah, all of its trade was maritime by definition.
Exactly. Yet, what makes the British perspective so compelling during this specific window is that its relative position in the world was shifting profoundly.
Which is fascinating.
Right. While global trade was seeing that 400% explosion, the UK's overall share of the global pie was actually halving. It dropped from 30% down to 15%.
The absolute volume of their trade was still climbing, but the rest of the world was waking up and growing even faster.
Right.
Now, let me apply a bit of modern skepticism here.
Sure, go for it.
A 50% drop in freight rates feels functionally identical to, say, the sudden availability of cheap, high-speed broadband in the early 2000s.
That is a great way to think about it.
Right. If you abruptly cut the cost of internet access in half, of course people are going to stream more movies. So, if it suddenly gets 50% cheaper to ship goods from New York to London, trade volumes are inevitably going to spike. If shipping gets 50% cheaper, of course people are going to trade more. Isn't this case closed? Why do these economists even need to write a paper about it?
Well, it is a completely natural assumption.
Yeah.
In fact, generations of highly respected historians and economists operated on that exact logic.
Wow, really?
Oh yeah, shipping got cheaper, therefore the trade boom happened. Case closed. But Jacks and Pendakar recognized that the historical foundation everyone was building this theory upon was, well, it was structurally unsound.
How so?
For decades, researchers were relying on a metric called the Easterly's Index to track these 19th-century shipping costs.
Okay.
The problem is that the Easterly's Index was essentially a blunt, flat, global average
Wait, averaging out global shipping? That seems incredibly reckless for tracking actual economic behavior.
It really was.
I mean, that is like averaging the cost of an Uber across Manhattan with the cost of chartering a private jet to Tokyo, and using that single number to explain transportation trends.
That is an excellent comparison. The Esarilis index failed to account for different commodities, and it entirely ignored specific geographic routes.
Oh, wow.
Yeah, it treated the cost of moving a ton of low-value coal from Cardiff to Paris as mathematically identical to moving a ton of high-value silk from Bombay to London.
Which makes no sense at all.
None. The dynamics of a short-haul route versus a long-haul route are fundamentally different, especially when you factor in the transition from wind-powered sails to coal-powered steamships.
Right, because steam engines revolutionized long-haul routes drastically, but offered much smaller cost reductions for quick trips across the English Channel.
Exactly. So, to figure out if cheaper shipping actually caused the boom, the authors had to throw out the old global average and rebuild a historical index from scratch.
And the scope of their data collection is staggering.
It is massive.
They didn't just pull a few summary ledgers from a museum. They painstakingly analyzed 5,247 specific individual shipping transactions.
Yeah, they manually extracted these data points from a massive array of historical shipping circulars and trade reports.
Just incredible.
They tracked 40 distinct commodities across 21 different countries.
And coal was the dominant variable here, right? Making up over 38% of their data points.
Yes.
Which aligns perfectly with Britain's status as the world's premier coal exporter at the time. But they also tracked grain, wheat, general provisions, and deals, which is a specific type of imported timber.
And by isolating these specific journeys, they created the very first bilateral country-pair-specific index for this historical period.
Bilateral meaning?
Meaning they could mathematically isolate a route from the United States to the UK and recognize that it behaved completely differently than a route coming from India.
Ah, got it.
It also allowed them to see how the cargo itself dictated the economics.
The source material highlights this beautifully. In 1870, if a merchant was moving cargo across the Atlantic, transporting grain cost roughly 30% of what it cost to transport cotton.
Right.
And by 1913, that ratio had dropped to 25%.
Because cotton was bulky and high value?
Exactly, whereas grain could be packed densely. The physical nature of the good determined the freight rate, independent of the ship carrying it.
What's fascinating here is that dealing with that level of granular, diverse historical data introduces a tremendous amount of statistical noise.
Sure, I can imagine.
To process it, the economist avoided imposing a preconceived mathematical shape onto the trends. Instead, they utilized a semi-parametric model, specifically employing a penalized B-spline smoother.
Wait, let me stop you there before we lose anyone in statistical jargon.
Do.
When you say a penalized B-spline smoother, are we basically just talking about drawing a highly flexible line through a scatter plot of data rather than forcing a rigid straight ruler onto the graph?
Precisely. A standard parametric model forces the data into a straight line, or a perfect curve. You are telling the data how it should behave.
Right.
A semi-parametric model with a B-spline allows the trend line to bend and flow naturally, following the actual dense clusters of historical data points across different decades.
And the penalized part.
The penalized aspect simply acts as a mathematical anchor. It prevents the line from zigzagging wildly every time a single anomaly or transcription error pops up in a given month.
Oh, that makes sense.
Yeah, it ensures you get a smooth, genuinely readable trend over the 43 years, letting the raw history dictate the shape.
Okay, so we throw out the flawed global average. We build this incredibly precise, route-by-route, flexible mathematical tool.
Right.
Here's where it gets really interesting. How does looking at highly specific commodity-by-commodity routes change our understanding of trade compared to just looking at a flat global average?
Well, the authors take this polished data and plug it into what economists call a gravity model of trade.
And for anyone unfamiliar, a gravity model essentially applies Newtonian physics to global markets.
Exactly.
It predicts trade flows based on the economic mass of two countries and the physical distance between them.
Right. Huge economies that are geographically close have a massive gravitational pull on each other's markets.
Which makes intuitive sense.
It does. It is a standard, highly reliable method for analyzing bilateral trade flows. So the authors ran a naive OLS regression, which is essentially a baseline statistical pass looking for direct correlations.
To see how their newly accurate freight rates impacted trade volumes.
Yes. And this is where the traditional historical narrative seemingly fractured.
The results were totally backwards.
Completely backward. The initial data pass showed a positive correlation,
Wait, meaning?
meaning higher freight rates were strongly associated with higher volumes of trade.
Which shatters the assumption that cheap shipping caused the boom.
Yes.
If low shipping costs were the primary catalyst for trade, then an increase in the cost of freight should immediately kill trade volume. But they were rising together.
This brings us to a fundamental economic trap known as endogeneity.
Endogeneity.
Right. For decades, historians were treating 19th-century freight rates as if they were an exogenous variable, an external independent force acting upon the market, much like a sudden shift in the weather.
Okay.
But a freight rate is simply a price. And any price in a free market is determined simultaneously by both the supply of the service and the demand for it.
Hold on. If the cost of the service is spiking at the exact same time the volume of the service is peaking, that is not a technology driving human behavior. That is modern-day surge pricing.
Walk through how you see that applying to 1870s steamships.
Think about opening a ride-sharing app after a massive stadium concert lets out.
Okay.
60,000 people all demand a ride at the exact same moment. The algorithm sees that massive surge in demand hitting a limited supply of drivers, so the price of a ride skyrockets.
Right, surge pricing.
Exactly. A ride that normally costs $20 suddenly costs $80. Now, if an alien looked at a spreadsheet of that night's data 100 years from now, they might see the highest prices of the month directly correlated with the highest volume of rides.
I see where you're going with this.
The alien might conclude, wow, humans are highly incentivized to take cars when they are incredibly expensive.
They would be fundamentally confusing the price for the catalyst.
Yes. The high price of the ride isn't causing people to travel. The massive, sudden human demand to get home is hitting the hard capacity limits of the local car fleet. That overwhelming demand is simultaneously causing the volume of rides to spike and the price to surge.
That is the exact mechanism defining the late 19th century maritime boom.
Wow.
In the short run, you have this unprecedented, explosive global demand for imports. Nations are industrializing, populations are growing, and consumer markets are starving for goods. This avalanche of demand hits the physical capacity constraints of the existing shipping industry. Building a steamship takes time. There are only so many holes in the water on any given day.
So they hit a bottleneck.
Exactly. Ships are operating at maximum capacity, ports are heavily congested, and because everyone is bidding for limited cargo space, shipping companies can charge an absolute premium.
And that's the endogeneity.
Yes. Endogeneity means the trade volume and the freight rates are locked in a continuous feedback loop, mutually influencing one another.
Which presents an enormous mathematical headache for these economists.
Oh, massive.
If they want to know whether the physical technology of the steamship independently boosted trade by lowering transport costs, they have to somehow untangle that feedback loop.
Right.
They have to mathematically filter out the surge pricing effect caused by everyone desperately wanting goods so they can look purely at the isolated supply of shipping.
And isolating the supply curve in historical macroeconomics requires serious ingenuity. To accomplish this, Jacques and Pendecourt utilized a statistical method involving instrumental variables.
Okay, what is that?
An instrumental variable is a piece of data that heavily influences the cost of running a shipping fleet, but has absolutely zero correlation with British consumer demand for imports.
So they needed a clean variable.
Exactly. They needed variables that affected supply, but were entirely disconnected from the economic forces driving demand.
And the variables they settled on are some of the most unexpectedly fascinating historical data points I've ever encountered.
We really are.
To decode global macroeconomic trends, these researchers started tracking the wages of Norwegian sailors.
It seems strangely specific, but the logic is airtight. The wage bill was a massive portion of a shipping company's operating costs.
Yeah.
However, the authors could not use British sailors' wages as their variable.
Why not?
British maritime wages were inextricably linked to the broader British business cycle. If the British economy was booming, import demand was high, and domestic wages rose.
Oh, I see. Using British wages would pull the math right back into the surge pricing trap.
Precisely. But Norwegian sailors operated as an internationally traded labor commodity.
Oh.
They crewed merchant vessels across various global fleets, regardless of the flag flying on the mast.
That is so smart. Therefore, fluctuations in Norwegian wages significantly impacted the global cost of supplying shipping capacity, but those wages were structurally divorced from the specific daily fluctuations of the British domestic economy.
Exactly. And they applied the same rigorous isolation to fuel costs by tracking UK coal prices.
Right, because coal was the lifeblood of the new steamship fleets. A spike in coal prices dramatically increased the cost of supplying a voyage.
But here's the trick. Yet the entire maritime shipping industry consumed only about 1.2 to 1.3% of total UK coal output.
Wait, really? Only 1%? Meaning a sudden boom in shipping demand wasn't large enough to single-handedly swing the national price of coal. The coal market was driven by domestic factors and home heating. Therefore, coal prices acted as a pure, uncontaminated indicator of supply-side costs.
You got it.
But it goes even deeper than fuel and foreign labor. The authors utilized fish prices.
This is where you really see the mechanics of historical local economies at play. How do you imagine local fish prices impacting global shipping supply?
Well, if there is a massive sudden boom in the local herring or cod catch, regional fish prices might fluctuate, but more importantly, the local labor force shifts.
Right.
Able-bodied sailors might temporarily abandon merchant shipping to work the highly lucrative local fishing fleets.
Exactly.
That creates an immediate labor shortage for the international maritime companies, driving up the cost of crewing a cargo ship. And importantly, a herring boom off the coast of Norway has absolutely nothing to do with whether a London tailor is experiencing high demand for imported Indian cotton.
It isolates the supply disruption perfectly. If we connect this to the bigger picture, it's just amazing. These economists are acting like historical detectives, using 19th century weather patterns and fish prices to solve a macroeconomic mystery. They also incorporated environmental data, specifically the annual variance of barometric pressures across key routes like the Baltic Sea, the Mediterranean, and the North Atlantic.
Tracking 19th century weather patterns to solve an economic debate. That is incredible.
Think about the mechanism. If the Baltic experiences a year of severe anomalous storms, sailing ships and early steamers are forced to wait out the weather or navigate much slower.
Right. Turnaround times plummet.
Exactly.
Right.
A ship that usually makes 5 voyages a year might only make 3. The weather artificially shrinks the available supply of shipping capacity, which drives up freight costs again, completely independent of consumer demand in the destination ports.
So once we use Norwegian sailors and barometers to filter out the demand surge, what is the actual isolated effect of cheaper maritime shipping on the global trade boom?
The results completely upend the traditional narrative. Once the data is instrumented and the demand effect is removed, the independent impact of maritime freight rates on the era's massive trade explosion drops to effectively zero.
It just disappears.
Statistically, the effect becomes small, negative, and completely insignificant.
Wow.
The transition to steamships and the 50% drop in shipping costs on their own did virtually nothing to cause the 400% explosion in global trade.
So what does this all mean? If the ships didn't build the modern connected world, what did? What actually drove the expansion?
The models point to an overwhelmingly dominant force: income growth.
Income growth.
Yeah. The simple, undeniable fact that nations were industrializing, populations were expanding, and people were becoming vastly richer explains over 75% of the entire trade boom.
75% just comes down to human beings having more wealth to spend.
Furthermore, a phenomenon known as income convergence accounts for an additional 18% of the boom.
What is income convergence?
Income convergence occurs when historically poorer nations begin to industrialize and catch up economically with the wealthier nations.
Okay.
This creates massive, newly balanced consumer markets capable of engaging in high-volume bilateral trade.
So when you combine raw income growth with global income convergence, you are looking at over 90% of the 19th century trade boom explained entirely by the world getting wealthier.
Exactly.
What about the rest of it?
The remaining fraction of the boom is attributed to minor systemic boosters. The widespread adoption of the gold standard increased trade by roughly 6.23%, simply because it provided a stable, predictable currency environment for international merchants.
Sure, that makes sense.
Lower exchange rate volatility added another 2.26%. And all of those positive forces easily steamrolled over a slight drag on the global economy caused by rising national tariffs, which pulled trade numbers down by a mere 1.4%.
This research demands a total paradigm shift in how we view technological history. The steamship didn't pull the global economy into the future. It was the exact opposite.
Exactly.
A mountain of human wealth and consumer demand was expanding so rapidly that it effectively forced the technological innovation of the steamship into existence. Shippers didn't build faster boats to encourage trade. They built faster boats because they were desperately trying to keep up with a world that was screaming for more cargo capacity.
Right.
Technology was the response, not the catalyst.
And what gives Jackson Pendecourt's conclusion such profound credibility is that it aligns perfectly with the research surrounding the next great era of globalization.
Oh, really?
Yeah. Decades later, economist Baer and Bergstrand analyzed the post-World War II trade boom, the era that actually did see the invention of the shipping container and the modern supertanker.
And what did they find about the mid-20th century?
The exact same dynamic. Baer and Bergstrand concluded that roughly two-thirds of the post-1950 growth in world trade was driven strictly by income growth.
Wow.
About a quarter was driven by international tariff reductions. Transport cost reductions and the shipping containers and supertankers accounted for less than one-tenth of the trade expansion.
That is wild.
Jackson Pendecourt proved that this behavioral reality was firmly in place a full century earlier. Humans generating wealth is the true engine of globalization. Technology is merely the tool we forge to accommodate the wealth we have already decided to generate.
That framework is incredibly clarifying. We started this deep dive looking at a 50% drop in freight rates alongside a massive spike in trade, assuming it was simple cause and effect.
Right.
But by digging into granular bilateral data, we uncovered the illusion of endogeneity, a massive era of global surge pricing. By the time the economists filtered the data through weather patterns and labor markets, the technological catalyst vanished.
It completely disappeared.
And this insight is vital for navigating the world you live in right now.
Definitely.
When you read the morning news and see a sweeping technological shift dominating the headlines, whether it is the sudden integration of artificial intelligence across industries or the automation of global supply chains, you have to look past the shiny new machine.
You really do.
You have to ask yourself, is this new technology independently changing human behavior? Or is a massive underlying shift in human demand simply pulling this new technology into existence to serve a need we already have?
It requires a level of critical thinking that refuses to take technological determinism at face value.
Yeah.
You have to locate the human driver behind the machine.
But before we close out this deep dive, there is one final historical breadcrumb buried in the source material that completely shifts the geographic focus of this conversation.
Oh, this is a great point to end on.
While the authors prove that maritime shipping across the oceans did not independently drive the trade boom, they point out that the story on dry land was radically different.
The internal domestic transport networks.
Exactly. During this same 1870 to 1913 window, the rapid expansion of railroad networks and the telegraph system caused overland freight costs to plummet.
And we aren't talking about a 50% drop like we saw in the oceans.
No. The paper notes that in some regions, the cost of moving goods over land fell by an astonishing 90%.
The economic implications of that are staggering. It effectively erased the economic friction between vast inland agricultural centers and the coastal ports.
Right.
The authors suggest this collapse in overland costs fundamentally unified fragmented internal markets, like tightly binding the U.S. Midwest to the East Coast.
Which leaves us with a truly provocative mystery. If the vast, dramatic journeys across the ocean weren't the actual catalyst for the death of distance, is it possible the real revolution happened entirely on land, right in our own backyards, before the cargo ever even saw a port?
It makes you wonder.
Did the relentless expansion of the railways quietly invent modern globalization, while the massive steamships simply took all the historical credit? That is something for you to ponder until our next deep dive.